Hi, this is the slides I'm going to use. We're talking about Chapter 2, Input, Processing, Calculations, and Printing in Python. And I want to emphasize how you can get to that point. So you go to Modules first, and then you go to Week 1 Lecture, and there will be a bunch of links here, or one link to the entire bunch of videos. If you are in online class, that is if you are in online class, and for every class there will be some kind of slides, and below there is additional information, for example Turtle, that you can look at and try Turtle on your own, and some examples of solving actual text problem. All right, so let us look at a few slides. So there won't be too much coding going on right away. We need to talk a little bit about what the code actually is and how to what the programming language is. Now, just like the regular languages, regular foreign languages, the only way to be successful with it is to practice it. That is, read, write, speak. And it is somewhat specific for programming languages, but the main idea is still there. The total time that you engage with the language and you try using it is what matters. So we are eventually practicing the skill of reading the story problem and producing a code from it. But step by step, first of all, you need to know what the language is about, or each new chapter you will learn something new about what the Python allows you to do. So let's start somewhere. Low-level language assembly is honestly the only one that I have seen. We're not going to talk about it. As far as I know, nobody talks about it at BPC, and that's okay. That is a language that actually goes into managing the memory and managing the commands to a very, very big detail. High-level languages is what you will see, Python, Java, and many other. That is a language that is designed to resemble human commands or logical structures that are easier for us to understand and work with. Now, there are two kinds of languages, compiled languages and interpreted languages. Compiled languages such as Java are going to compile, that is, pre-process the entire code that you have before executing it. Whereas interpreted languages will take one line or one coding statement and check it and then let it run. Both have advantages and disadvantages, and as we go on, you will see them. When we talk, if you go to the next class, which is the Java class, you will compare a compiled language Java with what you learned about the interpreted language Python, and you'll see advantages and disadvantages of each. In general, Python is known to be very beginner-friendly, very versatile, and very broad in terms of the modules and packages that comes with Python and allow you to do various things relatively easy. So Python is a language of choice when you want to develop something fast, whereas Java is more of a language which you want to use when you want your program to work faster. All right, so We will have keywords, that is predefined words in the programming languages. We will have operators such as multiply, divide, plus, minus, and so on. There will be syntax, just like with a regular language, the set of rules when writing a program. And statement will be an individual programming instruction. So let's talk about Python. I have a separate video about installing Python and idle or using alternative setups. Feel free to check this out. You will need an IDE or online IDE. IDE means Integrated Development Environment to program. So you can actually go to python.org and download Python and install it that way. In my videos, I recommend a different way of going about it. Either way is fine, as long as you can edit your code and run your code conveniently. Depending on whether or not you had any prior experience with Python, different solutions, different IDEs will be your favorite. Some of them are listed here. I would not include the last three as options. Ideally is included with Python. It is the easiest to use and understand. It doesn't provide too much prompt. Of course, it tells you about the errors, and it does more in version 3.11 than version 3.9. Visual Code is a professional development environment. I don't recommend starting from it right away because there will be a learning curve just to get used to using the environment, or Atom for that matter, or Sublime for that matter. Visual Studio Code is the most popular one. I may be using it for some of the things in the class, but you don't need to. You can use idle, or you can work in replit.com. All right. Now this is where I'm going to break probably some of the stereotypes that people have about the coding. We have a program development cycle, that is design the program, write the code, correct syntax errors, test the program, correct logic errors, go back to design the program. And this is a cycle. It's not like you are done when you reached this end, or often you are not done when you reach this end. Also, the size of each box in this diagram is the same, however, the time intensity is very different, and the intellectual effort is very different when doing each of these steps. And let me tell you that writing the code is the easiest and smallest step of all. If you have done a good job designing the program, then basically you have to type up the code, and that is really fast. Correcting syntax errors may look for a very beginner to be a big deal, but eventually it's not a big deal either. It is testing the program. It's an entire industry. You need how to test your program, and in our case we will just try it on various inputs. We will not actually write tests for the code. We're not there yet, but we will definitely test how it works. And the biggest steps are designing the program in the beginning and correcting the logic errors in the end. So a programmer, a software developer, is not a person who types code really fast and this code magically works. If that happens, well, the programmer solved some problem that was easy for that person, and that is usually, or always, not the way things work. unless somebody is very well trained into a certain kind of problem solving, prepared to the job interview, like some of the candidates that go to Google interviews and solve like job interview problems there. So that is yet another thing that you don't need to worry about right now. In any case, in any serious project, the very first and the very last are the most important. Now, what can happen is that you designed the program, wrote the code, corrected syntax errors, tested the program, and you find out that the program works, but it does something else. And that's the first question. How do we know it does something else? We need to have an idea about cases when we know the output of my program. What should happen when the program is done running? And if I anticipated to see something else compared to what I got on my screen, I will need to either rethink my expectations, or actually there is a logical error, and often they are. Maybe on some of the inputs the program works as expected, on some of the inputs it does something else. And that is where most of the intellectual effort goes. So correct logical errors, redesign some of the program, or actually go back and design the whole thing from scratch. Worst case scenario. Redesign the whole thing. All right. So design process. Understanding the task usually takes a very long time, and you repeatedly look into the requirements, into the problem description. To get a good problem description, you interview the customer. The customer might have a vague idea of what needs to be done, what needs to happen, and a part of understanding the task is actually documenting the, so to say, work order. Documenting the kind of app that needs to be created or the work that needs to be done. And it is up to a software developer or somebody who works with an actual customer to do that and actually agree to it. Because sometimes customer does not even understand quite well the difficulty of their desired software or the specifics of that software. Then determining the steps, that is algorithms. Algorithms and algebra are deeply related, but historically they were invented at the same time. Algorithm means a process of doing things. And as we go on, especially in the later chapters, we will see some interesting algorithms, such as loops, and maybe if we're lucky in the end, we will see some recursion. So algorithm is basically an order of doing things and breaking down the problem into smaller problems. Writing it out with pseudocode or with flowcharts. We will see some flowcharts. Feel free to open the book and look at them right now. If you flip some pages, and pseudocode is basically like vague code. And whichever programming language you're most comfortable with, your pseudocode eventually looks like that code. The idea is don't worry too much about little details. Write out the general process or present it as a chart. So there is syntax new in Python. This is now specific to Python. New lines are new instructions, and spacing matters, but only sometimes. And as you go on, we will make these ideas more specific. Flow. Generally, the program is executed from top to bottom. However, of course, there are loops and if-else statements, and we will talk about those as well. Functions. Function is a very important concept. in many languages. And basically it means a block of code that performs a task, usually single task. Good idea for a function to do one thing. This thing may be somewhat complicated, and the thing about functions, they can be named and reused. So if you have a function like cook breakfast, you can call this function whenever you like it in your life. And that function will be executed and presumably will cook breakfast early. Think of any other example, like perform single task, and basically you name it, and you somehow implement that task in a function, and then whenever you need this outcome, you are going to call this function. It may be very vague at this point, but we will be using function and actually creating functions soon enough. So Python has some built-in functions. That's our first order to see some of them today. And eventually we will write our own functions. And every function has definition arguments and return statement. The first function, print, and that's where we will begin coding.